S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. And that one met kind of the first part of our objective, which was talking about how to find geometric series. And in this case, this is finite. When we see, hey, it stops, we could see a last term. That means it's finite. Or if they tell us, find the sum of the first n equals 8 terms, that's finite. They're saying just this many, don't do any more. But it turns out there are certain, not all of them, but certain geometric series that are infinite, and we can still find what they add to it. So we did our little story about the bushels of wheat and saw that things were getting a little out of hand with the numbers there, and that's geometric. You know, they're going to continue up. So what happens to a geometric sequence when r is greater than 1? Well, we're multiplying by that number. It's going to get bigger and bigger and bigger. There's our dot, dot, dot. Bigger and bigger and bigger, depending on what we're doing. So really, it's growth. I mean, that's what it is. It's getting bigger, so it's going to grow. And unless they tell us, stop here, we're not going to be able to find a sum. It isn't going to happen. But this says what happens to a geometric sequence when you're using a number between 0 and 1. It does get small. Because there's something that's unique to the fractions between 0 and 1. If I said pick your favorite fraction between 0 and positive 1, what would you say?
1 over pi.
You'd be very unique, Justin. What's the one everybody likes to work with? If you have to work with a fraction?
1
A half. All right, so let's say I start you with the number 8, and I tell you this is geometric and that r is 1/2. What do you get for the next number? How about the next one? The next one.
1. No.
The next one.
1/2.
The next one.
1/4.
The next one.
1/8.
The next one.
1/16.
The next one.
1/32.
The next one.
1/64.
The next one.
1/28.
With your fingers, show me 1/128th of a centimeter. Come on, how centimeter about the big. With
Right
your
there.
fingers, show me 1/100. Are you having trouble trying to see some light in between your two fingers there? No, you can still see some light? Then you're not at 1/128.
I got intermediate. Hold on.
Eventually, it will become so small that it really adds nothing to this list. Nothing. And you'll say, oh, it's adding something, it's 1/128. But eventually, if we continue through this process and we're getting to numbers like 1 over 1 million, it's not adding a lot to it anymore. It's not. And so this is our first experience where we're going to talk about limits as far as our series go. So this one is, it doesn't grow, it decreases. So it gets smaller and smaller. I'm just going to put decreases on this one. And it decreases in such a way that eventually we are adding things that we can't even see with the human eye anymore. You know, 1 over 1 million centimeter. Oh, did I do that? I can't get it to show up. You know, it's just what happens. So when that happens, when it's getting smaller and smaller, and it's approaching 0, not quite getting there, but it's approaching it, that is converging. It is converging on 0. So they converge when we're using a fraction between 0 and 1. For r. Those we can find. Those, even though it's an infinite series, we can give them a number. We have a great formula for it. It's so small it makes you think, you gotta be kidding me. We have to go through all this to get to this formula and talk about limits. Well, as we keep going with our geometrics, and if we have a fraction between 0 and 1, we're getting closer and closer to 0. We're just not quite touching it. When does it diverge? That's when it just keeps getting bigger and bigger and bigger. So that's when r is greater than 1. So keeps getting bigger. Now, if that is an infinite series, we can't find it, because you could always multiply by r and get another number to add, and multiply by r again and get another number to add, and it just keeps growing and keeps growing. So we can't say, hey, I'm going to do this many. They said it was infinite. I'm supposed to keep going. It's going to get bigger and bigger and bigger. So what we want to focus on is which ones can we find? Which infinite geometric series can we find? And that's all going to be determined by r. If we see that r is a fraction between 0 and 1, it doesn't matter if it's positive or negative. If r is a fraction between 0 and 1, we can find it. We can give them a sum. So on the next page, I love this formula. It's so compact and small. Look at it. S equals a sub 1 over 1 minus r. Well, first off, I hope you're saying S, isn't there supposed to be a little n there? It's for infinite geometric series. There's not going to be a last term. There is no n for us to do. So an infinite geometric series with a first term of a sub 1 and a common ratio of r, notice it says the absolute value is going to be less than 1, which really tells us don't look at the positive or negative, just look at r. Is it a fraction between 0 and 1? It does have a finite sum. We can say, hey, this is what it's going to be. An infinite geometric series with the absolute value of r greater than or equal to 1? No, we can't do that. It's going to keep getting bigger. So it's all about that focus on r. And all we need, beautiful, first term and r. That's it. There's no work to that. We look at it, we say, hey, there's the first term, and they're multiplying by this, and bam, we've got our formula. So front page, let's get this on there. Remember there were two little blocks for the geometric series down there. This one is infinite, so write infinite next to it. And then grab that highlighter, because good news, all we need is a sub 1 and r.
That's good.
All we need.
Good.
No worries about n anymore. It's just s equals, because we're talking infinite. Short and sweet formula, you gotta love that. You should have noticed as we went through this chapter, and we learned more about sequences and series, that the formulas required less work. Really, the work was, can you punch it into the calculator without messing up? That was the work as we got to our finite geometric. So less things we have to find, more of let's just put it in the calculator and see what we get. So what we have to do first is determine, is this something we can do or not? And in order to be able to use our infinite geometric series, we have to know that r is a fraction between 0 and 1. We have to know that. So it says, does this converge, which means we can find it, because it's going to get closer and closer to 0, or diverge. If it diverges, we can't do it. So if it converges, what is the sum? Here's what we want to know. Well, first of all, it does say that it's a geometric series, but that's something we should really check. And what we have to do is take each term and divide it by the term before it, and see if that's always coming out to be the same thing. If it is, we have found r. Well, 1/2 divided by 1 is definitely 1/2. So the question is, does it equal 1/2 when you take 1/4 and you divide it by 1/2? Well, let's see, 1/4 times 2 over 1. Cross reduce if you want to, you're going to get 1/2, or multiply top times top, bottom times bottom, 2/4, and reduce it, you're going to get 1/2. Is 1/2 a fraction between 0 and 1? This is going to converge. So this converges is good. That means we can find it. And we can use a super easy little formula to do it. S equals, first term, bam, right there, over 1 minus r. Well, we just found r when we were checking to see if this is geometric. It's 1/2. Okay, what's 1 minus 1/2? 1/2. And a 1 over the top means we need the reciprocal of that. So what's the reciprocal of 1/2?
2.
We're done. Starting with the first term of 1, using a common ratio of 1/2, if u went on forever, this is going to approach 2. It's going to approach 2. Let's take a look at B. Which one of those is r when this is in sigma notation?
-5/4.
-5/4. Ignore the negative. We can't do it. Why?
Because it's over 1.
It is. This diverges. It's going to keep getting bigger and bigger and bigger. When things diverge, it means they're never coming together. Converge means coming together. So when they diverge, this is getting bigger and bigger and bigger. Never going to be we can't do that one. We can't. Here's why. Look what's up at the top of that sigma notation. Yeah. If they said 7, if this was from 0 to 7, do this. Oh, we could do that. Piece of cake. You know, use the finite. But it's infinite. It's diverging. We can't give it to them. We can't. So now, I know we only did the 1, but 4, 3, 2, 1, 0, me on how you feel so far about our new formula. Candy partners it is.
Yes.
So, get started on them. I'll get you candy partners. Probably you're going to want packet, writing, and if you're not comfortable with fractions, you might want to take a graphing calculator with you. Because these involve fractions.
I think I got your favorite. Good? Yeah.
All right, candy up in the air. Make eye contact with that candy partner and get out of your seat and go find them because somebody wants your seats.
Who's got the extreme? It's almost coming out of that.
You're gonna make me can't.
You know the drill. Talk to them about what you're doing, what they're doing. Somebody put chocolate back in there.
This is your class, so
Oh.
that's just all my homework. Yeah, I have some English event.
Scoop that. It's a great answer. Also a beer too. Sounds good. Haven't had
Some good conversations out there. This one is, they're flat out telling us it's infinite, but they wouldn't have to tell us. Take a look at this series and tell your partner what here tells us this is infinite if they didn't give us those instructions. Dot, dot, dot. That's what does it. So if it says, does the infinite series converge or diverge? First of all, we'd have to make sure this is geometric. So we'd have to say, is 3/4 divided by 1/2, is that going to be the same thing as 9/8 divided by 3/4? just to make sure this is geometric. Well, if we have 3/4 divided by 1/2, we have to take 3/4 times 2 over 1, and we do a little cross reducing here, and we would get 3/2. Well, then we have the other one, but do we even need to do the other one? Because can we do this problem? No, this diverges. It's more than 1. It's a fraction, yes, but is it a fraction between 0 and 1? No, this diverges. So part of the process was figuring out, what is r, and is r bigger than 1? And then for b, it was usually a negative mistake if somebody messed up. So most people could look at this and say, oh, look, they're multiplying by 1/3, but every other one is negative, so they're multiplying by negative 1/3. Now the negative doesn't matter. What matters is 1/3. That is a fraction between 0 and 1. So s equals a sub 1 divided by 1 minus r. And that's where people were tripping up a little bit. It was down there at the bottom with minus a negative. That'll be a plus a negative. So this will be 1/3 divided by 4/3. And we multiply by the reciprocal. And the 3's will cancel. And we get 1/4. So it looks impressive. I mean, look at all these numbers. But if you add them up forever, 1/4. That's all it's going to approach. That's little bitty 1/4. It is crazy. Now on C, a lot of you focused only on the first part of what I had said when we did the problem with negative 5/4. You looked at this and you said, can't do it because it's infinite. No, we have to check. We might be able to do it. We might not. It all depends on what is r. And the other thing people were having trouble with was, how do you know r? Whatever's being raised to the power, remember our formula. Now, it might not be n minus 1, but it's got to be a power. It has to be. So this is r. r is 2/3. If there's not an a sub 1 there, what is a sub 1? 1. 1. And you could always put the 1 up in here. That's got to be a 1 times 2/3 to the n. So we'll have s equals 1 over 1 minus 2/3. 1 minus 2/3. Oh, wait a minute. Not in this one. Hang on.
Oh, yeah. That's what I thought.
Why is this one different? It's not n minus 1.
I explain.
Eli.
So,
Go ahead.
since it's 2/3 is a1 and r, there's no n minus 1 in the top. It's just n because pure genius right there.
Right there. So remember we had talked before about how if it's not n minus 1, sometimes you can't just grab what's there. What you have to do is actually put that first number in and see what you get to get the first number. So a 1 in here would make this 2/3, and that will give us 2/3 over 1 minus, and 2/3 is also our r value. So this will be 2/3 divided by 1/3, which is 2/3 times 3 over 1, which is 2. Yeah. I didn't catch that as I was walking around either. I looking for my n minus 1 up there. Didn't catch it. Now, D says, will an infinite geometric series converge or diverge? Are those the only two options? What'd you and your partner say? Yes or no? Are those the only two options?
I'll be honest, I didn't see that.
We didn't even do
Uh-oh. All right. Take a minute, talk about D. Talk about it, see what you got.
It will. Yeah. So it's technically a little more, but it will get
It's gonna do one or the other.
Depends on so it's kind of both. But it's just saying that we'll have options.
You're gonna put down yes, but
Jordan,
I'm not
Jordan, it depends.
Yes or no? Are there only two choices? It either converges or it diverges.
Oh, that's what it's asking.
So if it doesn't converge and it doesn't diverge, then you have to say, well, what else could it possibly do?
give up and cry.
Exterminate.
Here's the issue. We know that if we have a fraction between 0 and 1, it's going to converge. We know if we have a fraction that's bigger than 1, it's going to diverge. So the one issue that we need to figure out is, what if r is 1? I mean, we haven't seen it, but what if r is 1? And you wrote out all the terms, and you were supposed to do that an infinite amount of times. Would it converge or diverge, or would it do something else? It's going to diverge. So it is converge or diverge. Those are your only options. Converges or diverges. So if r is a fraction between 0 and 1, it's going to converge. And if r is greater than or equal to 1, again, absolute value, we don't care about the plus or minus piece. That means it's going to diverge.
Get the book now.
Has to. Has to. Well, tell your partner thank you for their work.
Thank you. I'll find out who did that hit run.
We met our objective.
I am understanding math.
We met our objective and then some. You know, that one kind of trick problem where they started with n instead of n minus 1.
I got it.
Good catch, those of you that did.
I just
Didn't notice it until I was writing it down. I'm like, oh, rats. No n minus 1, we've got to put in that n term to figure out what it is. Yeah,
this is attaching to that.
good stuff.
The last time I wrote down the whole.
Now, do you remember disliking 9-1 incredibly because it was all trial and error?
Yes.
If we went back to it now, probably 2/3 of it we would be able to use one of our rules for, and it wouldn't be so bad anymore. You know?
I'm so cry over there.
There is going to be one trial and error one on the test. One trial and
that's
error.
me.
Hopefully it's just like
Formula.
+5.
Well, it could be that easy, or we would have made it work better.
Why the even? I got it's gonna be n squared plus.
It's gonna be like the end of the cubic root.
That was gonna be like
Cube root of 1 over y times 12 to the 5th.
I'm rover.
It's gonna be like,
Dude.
Sally has 3 oranges, and a cow eats 50 cows. Let's just try to do the sum.
What?